expression uh, of potential energy, potential potential energy of a dipole dipole in an uniform electric field. Now see, uh, we will write this in this manner that we apply an external torque arc, uh, uh, which will make the dipole move very slowly, and we move it, rotate it rather. We rotate it in the direction of d theta is equal to d theta k. Let us understand what is this, how to understand this. This is your x-axis, this is your x-axis, this is your y-axis, this is your z-axis. Now we move this theta, we move the dipole. So the dipole is something, we move it very slowly from here to here. We move it very slowly in this direction. So basically, we are moving in this manner. The d theta is directed, d theta, see, we move in this manner. D theta is directed in the sense of d theta k. Now, the applied torque is opposite to that of conservative torque. The torque applied is nothing but minus of PE minus PE sine theta k vector. That is nothing but PE sine theta k vector. Now, work done by the applied torque, work done by the applied torque is given by W applied is equal to, from initial state to final position, is given by torque applied dot d theta vector. This has to be in vector form. Now d theta already you know is this, because of this. Because see, if the thing is rotated in this manner, then the direction of d theta would be in this case. The direction of d theta will be in the direction of the z-axis. This is the z-axis. This is your x coordinate and this is your y coordinate, as I told you here. Now this is W applied is equal to, now from initial position, initial angle to the final angle, torque applied is PE sine theta k vector dot d theta is this one, d dot d theta k vector. K dot k is 1. K dot k according to scalar product, it is 1. So now what you have is W applied is equal to theta initial to theta final. This is PE sine theta d theta. Now let's integrate. This is nothing but P minus PE cos theta lower limit by upper limit. So this becomes W applied is equal to minus PE cos theta final minus cos theta initial. Now this is this. Now suppose if theta initial is 90 degree and theta final is theta degree, then W applied becomes minus PE cos theta minus cos 90, and cos 90 is 0. Cos 90 degree is 0. This is nothing but W applied. W applied is minus PE cos theta, and this is nothing but minus P dot E vector in vector form. Now, from the work energy theorem, W equal to delta K, this is the work energy theorem, work energy theorems. Wait a minute, energy theorem. From the work energy theorem, this is from the work energy theorem, you have W, this W means, this total W, this net W is nothing but work applied, work non-conservative plus work conservative is equal to delta K. Now, as we are not moving it very slowly, as things are moving very slowly, as the dipole is moved slowly, is moved very slowly, there is no acceleration, slowly, so delta K is 0 and W non-conservative is also 0. Therefore, what you have is WA plus W conservative is equal to 0. Now, one thing I like to tell you here, W applied is nothing but minus of W conservative. Now, and W conservative gives me, is by definition, is change in potential energy. So, comparing all this, W applied is equal to W minus WC is equal to delta U. So, W applied we just found out. W applied was how much? We had this quantity, W applied, this quantity. So, we will see. Now, W applied is minus P dot E. This is nothing but minus WC. This is nothing but here U delta U. So, delta U is minus PE, P dot E dot. So, from here, U final minus U initial is equal to minus P dot E. Now, at theta 90, that is theta initial, theta 90, U initial is 0. At theta final, that is theta, as I told you earlier, U final is nothing but U. So, what you have is U minus 0, so no need to write minus 0. So, U is, the potential energy is minus P dot E, this is a dot product. Now, let us see, now what is work conservative? Work conservative is nothing but minus, that is basically minus of work applied, and work applied is what? Minus of P dot E. So, work conservative comes out to be P dot E dot. Try to understand the difference. This is work conservative. This one was your work applied. This one, I mean to say this whole thing. This whole thing was work applied. So they are opposite to each other. Now let us try to find out work conservative directly. Now work conservative will be theta initial to theta final, torque conservative into d theta vector. Now this is going to be minus Pe sine theta k vector. Let me write it in bracket, this one, and this is theta initial to theta final, and dot d theta k vector. Now W conservative is equal to minus theta initial to theta final, k dot k is 1 by dot product. This is Pe sine theta d theta. Now integrate this, we get plus Pe cos theta final minus cos theta initial. As usual, let us consider at theta I equal to 90, initial 90, at theta initially it is 90 and it goes to, and theta final is theta. So what you get is work conservative from here, Pe cos theta minus cos 90, and this is nothing but a Pe cos theta. Therefore, work conservative is P dot E dot vector, which I have derived independently. Basically, this should always be the case. Work conservative should be this, work potential energy should be this, and they should all agree to this equation. This is a very, very important equation. They all should agree. ये यहाँ पे सारे agree करने चाहिए. This equation must be agreed. Work applied minus work conservative is equal to delta U. This must agree at all times. Whether it may be gravitational, whether it may be electrical or whatever, it should always agree. This is a standard format. You cannot change this equation. This equation must always agree. That's the thing, basically. So let me write in one short line. Work conservative is P dot E dot. Work applied is minus P dot E dot. And potential energy is minus P dot E dot vectors. This is what it is.